Like, you know what page number it is. Like, you know, oh, I have, like, section 1.5 I have written on. Like, 'cause that's where the page is from in your book. You can go on my website and find section 1.5, and it'll tell you all the pages. So if you check my website, it'll like, oh, and it's like every day we did section 1.5, but it's always at the bottom. For what?
It's called diamonds.
Yeah, because
No,
you
because
shuffle,
when
yeah,
I'm
you
entering like
shuffle,
this,
and then you have to squat and pick it out, and then
Do you practice with them?
I don't like actually practice, but I do. But
I put it in JC,
so it's
and
like
I put it on my website, but then I
video
can't fit it
that
into
I
the
just
grade book or the grade show. It won't show.
and very first
That's
thing,
usually what I
the
always
kid
do
comes
is
around,
just
crowd
grade
just turns
separate
around.
seconds.
Honestly,
And I always
or
say that's where it's made like right here. Well, it only says
I feel like whenever I have no like you
I don't know why they were talking about every
I
time
don't
I
know,
say
it's
that.
just
It always
scratch.
says
Yeah.
they.
What do you do?
They. They. Like,
time flies.
I don't know what you're talking about.
Oh, you're so sassy.
So sad.
Mr. Ward,
I don't know what you're
last night I was typing. I was
The
gonna look the word
diamond
is.
fly.
I forgot
Diamond
I.
fly
I went
forward.
H. I corrected the HS math.
Hey, look at that.
I'm like,
Come
what
on,
the
Lord.
Once I start getting more people visiting that website,
Well, you're gonna sit this long or something?
I know that's why I went already. I was like, I gotta go. I don't.
What's the math of it?
I don't want ads. That's the last
I
thing.
told Jack
Because when I see ads on the website that are like
oh,
blatantly
my mom's not
terrible,
together.
I'll never visit the
Oh,
website.
cool. And he didn't tell her happy birthday, so I told her. He goes,
Oh! It's on the birthday?
yeah.
How was the love of my life?
Okay, let's do a quick review of what your homework was like yesterday. In fact, I might give you a couple freebies here just so you can see it. So, again, the section we're on, 3.5 to 3.7, that's kind of the sections that we're in. We mostly spent most time on 3.5, 3.6 kind of thing. But what we're dealing with here is on fractions, because that's kind of the title of the chapter, right? What we looked at yesterday was how to simplify. That was a main goal yesterday. So, simplifying fractions. So that was any type. Now the main types that we discussed yesterday, I should say Wednesday when I was actually here, we talked about mixed numbers and improper. Okay, those are the types of fractions we really focused on. And then we did that, I think we did like one example where we mixed them together. I gave you a mixed number but it had an improper in it. That type of thing. So we'll do one quick review. I might pick a couple times from the books if you did it right. And then the last thing that we should have done some basic operations with fractions. So the first one we introduced on Wednesday this week with basic operations, we talked about how to multiply. That was the big deal. We talked about how, multiplication of fractions. And I want to review that today. Our goal today, if we can, I want to talk about division today. And really talk about like what it is, why do you get certain numbers, why is it this value, what does that mean, that type of thing. Okay, questions about what we're going to try to attempt to do today? Okay, and again, you'll have some time where you can work on page 67, 68, that type of thing, where that's due Monday. Okay, let's jump right into it. In fact, I might just pick a couple problems from the books, that way we have something to kind of look at, in case you're actually working on that assignment. So I'm going to start with page 67. I'm going to pick, exercise B, so I'm going to pick, okay. All right, let's pick this one. 8 2/6. My first example from this is from page 67. Okay, I believe it's problem number 4. I think it's problem number 4. Okay, what you have to do on this problem, we have to simplify this down. Now the good news is we do not have improper. So what we're going to do is we're going to try to simplify this fraction down to something simple. Okay, the 8 is going to stay there. With a fraction, I want this to change to something else. So this is kind of our goal, what I want to get to. Okay, Now, when we simplify that 2, 6, this is how I want you to do it. So the 2, 6, I want you to break up what are numbers that multiply to give you 2, the number 2 on the top. What are numbers that multiply to give you 2?
1, 2.
1 and 2, okay? All right, so 1 times 2, that gives you the number 2. What about the 6 on the bottom?
2 and 3.
2 and 3, okay? So that's the number 6, right? So now that we have that, now you can cross out the numbers that they both share. That's what we talked about Wednesday. So like the 2's are gone. Boom, boom, those are gone because that's what they're sharing. So this fraction actually simplifies to be the numbers that are left, 1 and 3. There's always going to be a 1 there, just so you know that. And that's the numbers that go here, the 1/3. That is the same as 2, 6. Okay, because those are the numbers that are left. Now, if there's multiple numbers that are left on the bottom, you just multiply those numbers together, and that'll be your new bottom after you simplified it all the way. Okay, questions on this one? This was problem number 4. So if you're kind of checking, did you get the right number? Again, we're doing part B on those. Okay, now the next one I want to pick. 6 and 12 fourths. So next example, 6 and 12 fourths. I believe this is problem number 6, I believe. Okay. This is a goofy one. The reason why I was kind of looking at this one's going to cause a problem. It's got one little weird part to it. So the first thing is, if you notice, we have a mixed number, okay? So it's got a fraction behind. The fraction in the back is improper. It's got a big number on the top, small number on the bottom. So what we need to do first, we need to change this. We need to change this fraction to be a big number and then a fraction behind it, if it has one. And then when we actually simplify that, then whatever that is, we'll add it to the 6 that's already sitting there. This number hasn't changed. Okay, that's kind of our goal. We're going to simplify that improper. Now, when you do that, I don't care if you're doing like the subtraction rule, where you subtract 4 from the how many times you count, how many times you can subtract it, or if we just do, I think the one that you guys are always comfortable with, you put the 12 in the house, you do long division. That's what a lot of us do. So, how many times can 4 go into 12 without going over? 3, right? 4 times 3 is exactly 12. When you subtract, you get 0. The good news is you don't have a remainder. So technically, that 12 fourths, the 12 fourths as a mixed number is obviously the big number 3, which was here. That's your big number, and the remainder was 0 out of 4. Right? That was the remainder you had out of the 4 that you divided by. So you don't need that fraction in the back. You don't need it. Since there's a 0 there, you don't need it. So really, this number here, it's the 3 and 0 fourths. I don't need this fraction at all. So really, your final answer is just what is 6 plus 3? That's your answer. There's going to be no fraction behind it. Now, let's say that the fraction didn't have a 0 there. Let's say it was like 1 out of 4. That was a 1/4. Your answer at the very end would be 9 and 1/4. Because you just put the fraction behind it. Okay. Makes sense? That was kind of a goofy one I saw. I better talk about it. Okay, that was, I believe, number 6 on page 67. That's basically what you have to do. Very, very easy problem. Okay, any questions from that page 67? Like, no, this one, I just want to check that kind of thing, so just kind of give you a couple freebies. Okay, let's go to 68. 68 was the one where you had to multiply fractions. That was the new thing we introduced Wednesday. And I want to make sure that we know how to do that correctly. So we're multiplying fractions here. Okay. Okay, so I'm going to pick a problem from page 67. I believe we're just doing the ones at the top. There's only one type of problem. I'm going to do problem number... Do problem... Oh, there's not a lot here. Let's do problem number 9. I believe it's 5/11 times 4/6. Correct? Something like that. Number 9, 5/11, 4/6. Okay. So what we're going to try to do is we're trying to multiply fractions. Now, the rule we talked about Wednesday, when you multiply fractions, you technically just multiply straight across, top and bottom. You don't need to get common denominators or anything like that. So really, what most people do is when they look at that problem, they just multiply across and they say, oh, it's the answer on the top is 20, because it technically is. And the bottom, if I take 11 times 6, I get 66. So it's 20 out of 66. Fine. Yeah, that is the correct answer. But I want it simplified. Can we simplify these problems? So if we can simplify, what I mean by that, the first thing I always check for, can I simplify things top and bottom? So like for the number 5 and 11, right? 5 is 5 times 1, 11 is 11 times 1. So really the only thing that they have in common is like 1, so I can get rid of those. So that's not a big deal. Everything has a 1. Right? The number 4, what is the number 4 written out as? What are the numbers that multiply to be 4? 2 and 2. What about 6?
2 and 3.
2 and 3, okay. And then what we can do is top and bottom, we can cross out like the 2's there. Those like top, bottom. That's the first thing. It's always, you're simplifying the fraction top down. So we're going to simplify fractions. And I believe what the book tends to call that is called fractional simplification, when you're simplifying numbers top down. Then what you're allowed to do is after that's done, so now I crossed out all those numbers that they had in common, so it's like this so far, right? This is what we're down to. Then once I've crossed out numbers top down, then what I do is I look diagonal. Do these have anything in common still? No. Do these numbers have anything in common? No. And if there's like a number that's still sitting there, that like maybe they both have 3s, you can cross out the 3s, that kind of thing. So there's nothing that they have in common. So once you're to this point, so we've simplified diagonally, so we're here now. Now we can just go straight across. Because now these numbers are as small as they can be, and I'll get my final answer here. So if I go straight across, what's 5 times 2? 3 times 11? 33. That's your final answer.
Are you okay with them just multiplying and then simplifying?
That's fine. I always simplify first. It makes the number smaller. It's easier to do it in my head. If you multiply straight across first, and then maybe break those up later, that's fine too. It's the same math. I like to do this first because it gets me smaller numbers and I can do that. But yeah, if you want to just, if you want to write right away 20 over 66 and then break those numbers up further, that's fine. You get the same 10 over 33. Okay, questions with that one? Now, is there another one on the page that you just kind of want to see? You want to see if you did it right? There wasn't a lot you can simplify. Well, what do you got? 12. Okay, give me. Can you say that problem out loud so I can write it up here? Hold on, let me get a marker here. Take a look at number 12. I think that was one of the only problems that you could actually, you could really simplify it. Like this one didn't go really far. Okay, so.
One was 5 over 16.
5 over 16 times?
Then times 8 over 9.
8 over 9. Okay. So the first step that I always attempt, I always try to attempt simplifying top down. So I always break these up. If you're that person that wants to go across and say that's 40 over, 40 over what, 51 or something like that, 151 or 151, something like that. If you want to do that, that's fine. It's just, I like to simplify first. That's just my style. So the number 5 is 5 times 1. What is 16 though? 4 times 4, and we can break up the 4s instead of doing 2 and 2, 2 and 2. Now, if you're that person that thought 16 is 2 and 8, then you break up 8 even further to be 4 and 2, and then break down 4 to be 2 and 2, and this is what you get for the 16. What about 8? That's what 2 and 4, and then I break up the 4 even further to be 2 and 2. And 9 on the bottom, 3 and 3. Okay, so I've broken up all these numbers into everything I possibly can. And now what I'm going to start doing is I'm going to start crossing out. Is there anything top and bottom I can cross out here and here? No. So they don't have anything coming. All right, now that we're here, nothing goes top down. That's the fractional simplification. Now I'm going diagonal simplifying. So simplify diagonally. So diagonally this way they don't have anything in common, but this way they do. They have 2's, another 2, and another 2. That's kind of nice. So I simplified those 2's because those are the things they have in common. And now I can go straight across. And I can now write my final answer where it's multiplying the numbers that are left on the top altogether. So 5 times 1, and there's nothing left over here. So what's 5 times 1? 5. Okay. There's a 2 left over here, and then there's a 3 times 3. So 3 times 3 is 9, and we have to take that times the 2, which is
18.
18, and that's your answer. That's the simplest form of this fraction, or of that multiplication problem. Now I know that original answer would have been 40 over 151, but it's something like that. I think it's 151. Okay, questions with that? All right. Actually, no, 146. Is that what it is? What's 16? 144. Yeah, that's it. All right. Okay. Any other questions from this assignment? Now, if you did them right, you feel comfortable, like those 3 particular people I handed back the papers, you can commit it if you're done. If you're comfortable with it, put it back in the basket. I'll grade it. But I want to make sure everyone else gets some time. We'll give you some time right before lunch here if you need to kind of work on this. I think we have lunch in about 5 minutes or so, so I'll give you some time if you need to work. I'll try to get this done. Remember, the people that still owe me something, Alex, you owe me an assignment. Beth and Sean, you owe me assignments. So make sure you check your grade book, see what you still owe me. No, yeah, it's fine. Yeah.
That's about the only thing I did.
Okay. We have lunch in what, a couple minutes here?
Yeah, 33.
33, yeah, so about 5 minutes. Actually, 39. Yeah, 39. So about 9 minutes. You can work. Yeah, back to the course. Again, big thing when I hand back papers, always hold on to them. See, maybe I'm handing you back something that I didn't put in the grade book or I entered it wrong. That's something you should always check. I'm not perfect. Every once in a while I do make mistakes. Everything's in the grade book as of this month except for this page 67. So. I'm not quite sure what assignment that was because you already had page 161. So I don't know if you were like redoing it. I'm not sure. So let me just hand it back to you because you already had a 161 for this, but it was the second page, page 62, and I never got it. I don't know if that was 62, but you never finished it. So here you go. That was the one that I graded, and that was a better score on the first page. So yeah, I was confused about that. Again, you can always do fixes, so if you're going to fix a problem, turn it back in, you can always do that.
What about this one? It's obvious.
Oh, because of like which fraction's bigger? Yeah, so that's fine. You just had to draw the right arrow to go in the right direction.
Can I fix it?
Yeah, oh yeah, you can fix. Yeah, so remember, you can always fix the mistakes that you make and turn it back down. So yeah, like that one, definitely fix. That's an easy fix. These are the tests we went over about a week ago, I think. And again, you always have about a week if you're going to choose to make fixes, turn it back in, that type of thing. Stay down here. How are you? Okay, let's talk about dividing. Let's talk about dividing fractions today. That's something we haven't talked about. Okay, so let's start with this idea of numbers like this. Just whole numbers, right? Division. 10 divided by 2. What do you think? 5. Okay. All right. So let's talk about what that means. So I do want you to have a sense of like, what does this actually mean to divide, right? So this idea of division, that you're taking numbers, like whole numbers or whatever that is, and you're dividing into smaller piles, right? So I'm taking, $10. So here's $10. I'm going to draw this out so you can see this. Sorry, here's 5, and here is, all right, so 10 individual dollars. And what you're going to do is you're going to divide your $10 into 2 separate piles. That's what it's saying. 2 separate piles. So there's one pile up here, one pile down there. How many dollars are in each pile? That's what it's actually asking you. That's the mentality that you're thinking of when you divide. Dividing into 2 separate piles. How much are in each? There's $5 in each pile. Okay. Now, what does it mean for fractions? That's the goofy part. So half divided by 2/3. This is the goofiest thing you'll ever see. All right, you're starting with half. So the idea is that maybe I'll put it this way. You have half a dollar bill. Okay? So half a dollar bill. And what you're going to do is you're going to divide that up into 2/3, 2/3 of that size. That is the goofiest thing to explain to somebody, because for whole numbers, it makes sense. Taking $10, you're dividing into 2 piles. I'm taking half a dollar, and I'm dividing it not into like 3 piles. I'm dividing it into a 2/3 pile of something. So it's just the goofiest way to think about this. So I think the easiest way to explain it is, imagine you had a pile of pennies, right? Just a stack of pennies in front of you. And what you're going to do is you're going to divide those, because pennies are like a fraction of a dollar. You're going to divide those into smaller groups. And what's going to happen is if you have some pennies and you're dividing them up into smaller chunks, smaller pieces, you're going to have a lot of pieces. That's the idea. So when you divide by fractions, your answer that you're going to get is actually going to be larger than what you originally started with, like the half-dollar bill. Or if I started with a bunch of pennies, your answer, if I'm dividing these pennies into smaller piles where you're cutting the pennies up with like a scissor, you're going to have a larger number than what you started with originally. That's the concept. Now, I know that's kind of hard to wrap your head around, but I want to show you the process for how we divide. And it's actually really simple. First step. It's going to seem a little goofy, but it's actually really straightforward. You change the division sign to multiplication. I'm going to change that to multiplication. Now, if you want to use that little X symbol, you can do that. I'm going to use a little dot. Okay? And when you do that, the second fraction you have, so this is the second fraction, right? That 2/3. that fraction will flip over. You're going to do the reciprocal of that fraction. This is called the reciprocal. You're actually multiplying by its flip. And notice, I'm multiplying now. So when you multiply, what do? Questions?
Yeah.
Or you guys know the answer?
What if you just still multiply
You
across?
now you've changed it to multiplying. Now it's just multiplying straight across. What do you get?
So it would be 3 over 4?
3 over 4. Because you're going to multiply straight across, and your answer is 3 out of 4. Now what that is, what you're looking at there, that answer is bigger than what you started with. Wrap your head around that. I started with a $50 bill. I broke it up into smaller piles, and my final number is actually a bigger number than what I started with. Doesn't mean you have more money. Don't get me wrong. I don't have more money. I have a number. The number of piles I have, there are more of them than what I originally started with. Right? That's the idea. Like over here, when you're dividing whole numbers, you're trying to find out how much money you're handing to each person. Okay? But what I'm actually doing there is trying to figure out like how many piles do I have. Okay, that's the idea. Okay? Alright, so I'm going to apply the same concept to this problem we just started with a little bit ago. You guys told me the answer. What's 10 divided by 2 again? 5. Okay. I'm going to show you the justification why we do what I just showed you. Like why we flip the fraction, why we divide. And we actually change it to multiply, correct? Okay. Can I write the number 10 as a fraction? Think about this, yes. How do I write the number 10 as a fraction? What do you remember from like basic algebra? No. The number 10, like that whole number 10. How do you make that number a fraction by itself? There's this little rule we do.
Back over to.
You do it like this. Everyone see that? Like, you make a whole number into a fraction, you put a 1 on the bottom. You can take any whole number you want, and if you want to make it a fraction, you can always put the 1 on the bottom. Okay, now what about the number 2? How do I make that a fraction?
That would be...
I heard it. 2 over 1. Same rule. Does that make sense right now? I can make whole numbers into fractions. Now, we have division. Technically, when we divide, what we do is we change this little symbol. You change the symbol to multiplication, so I'm going to use a little dot. You can use a little times symbol, it's fine. Use a little dot. And what happens to the second fraction? It flips, right? That was the rule I just showed you there a little bit ago. The second fraction does the reciprocal. Does that make sense? And now the idea here is we're now multiplying fractions together. So this is what we're at. So we're at 10 over 1, we're at 1 over 2. And the rule is, like what we just showed you in that last section when we multiplied, bless you, there. What we learned in the last section is that how we actually multiply fractions. You simplify before you actually multiply them across. Right? I know you can multiply straight across, but we can actually simplify. Like the number 10, what are numbers that multiply to give you 10?
5 and 2.
5 and 2 or 2 and 5, however you want to think of it, right? And the number 1, yeah, it's just a 1. What about the number 2?
1, 2.
Yeah, 1 and 2, 2 and 1, whatever you want to think of. And then what you do is you simplify, right? I simplify it up and down. They have 1s in common. Yeah, I don't need those. Up and down, nothing. Then I go diagonal, and the 2's would be gone because those are diagonally. And what you do is when you go straight across, there's a 5 left on the top. There's a 1 left on the bottom. And what is the number 5 over 1 the same as? 5. That's why your answer always works. Like I'm trying to show you, like when you divide fractions, you actually multiply. You're actually multiplying. This is how, what you're looking at right now is the reason why multiplication and division are literally the same operation. You can choose to multiply or you can divide. They're the same thing because you're just doing the little flip. You do the reciprocal idea, that little flip. And it works every single time. It will prove that you will get the same results. Okay, does that make sense? I just wanted to show you that. So if I, over here earlier we were talking about, when you take a whole number and you divide it into like two separate piles. What I'm doing here, if I choose to do like a whole number, right? In fact, I'm gonna choose a whole number. Let's say I choose like the number. Let's say I choose the number. I don't know. Let's choose like the number 10. Let's say. Okay, actually not 10. Let me just use 10. Let's go 12. All right, let's pick a 12. All right, so I have $12, and I'm gonna divide it into not two separate piles. I'm gonna divide it up into piles of 2/3 of a penny. So what 2/3 are in like decimal form? I'm breaking up $12 into separate piles. So this is $12, right? Here's $12 if I draw it. 6, 7, 8, 9, 10, 11, and 12. What I'm going to do is I'm going to break the $12 into separate piles where they're all worth this amount of money. That's how I'm thinking of it. So what 2/3 is, like as a number, it's 0.6. It's actually like 66 cents. That's what we're doing. Okay, so it's 66 cents. That's what I'm doing. So I'm taking $12, I'm dividing it into piles of 66 cents. Now, in each of these dollars, would you agree that there is at least 66 cents in that dollar?
Yes.
There'll be a little bit extra, but there's at least that. So what we're doing is we're going to be breaking up all of these dollar bills into separate piles of money, separate pennies. 66 cents, 66 cents. You're going to start grouping them up. So I'm exchanging all these dollars for pennies, and I'm making separate piles of them. What you're going to find is that we're going to have a lot of piles of pennies. Not just 12 piles of pennies, because I have $12. I'm going to have multiple piles, because I'm taking these dollars and I'm breaking them up to make pennies, so there's going to be a ton of them. So to show you what this answer is, when I divide $12 into 2/3, right, divide it by 2/3, this is what you do. You change the 12 into a fraction. How do I change 12 into a fraction? 12 1. Okay, good. I'm going to multiply by the second fraction. So I'm going to multiply by 3/2. So you have to flip, right? We changed it to multiplication, so we flip the second fraction. That's called a reciprocal. And now I can multiply. So you can either go straight across, or you can do that little thing where you simplify. Like number 12 is 2 times 6. 3 is 3 and 1, and 2 is 2 and 1. 6 can be broken up even further to be 2 and 3. And then now I can look up and down, nothing, up and down, and I can get rid of these ones. Diagonally, it looks like I can get rid of the 2 here. And so the 2's are gone, and that's pretty much about it. That's the only thing I can really cancel out. And now I'm going to go straight across. So the top is going to turn out to be, that's 2 times 3, which is 6, times 3 is 18. And I have a 1 on the bottom. And so what this means is that my answer is 18. Isn't that weird? I took 12, divided by a fraction, and I got a number that was bigger than what my original number was. Because what this is actually doing is I'm trying to figure out how many piles, this is the number of piles that I'll have of these pennies. I'm separating $12 into 66 pennies. Each pile separate. There will be 18 piles of it. That's what's going to happen. All right, does that help you visually think about what we're doing? Because some people, they really understand this. Okay, I took $10, divided amongst my 2 best friends, they had $5 each. But when you start doing fractions, it's so hard to explain that. You're dividing money into piles of pennies. So there's more piles. There's just it's a larger number. That's the idea. Doesn't mean I have more money, I just have more piles of them. That's the idea. Okay, we're done for the day. That was it. I just wanted to cover that. We're going to look at this stuff on Monday. But Monday, what we're going to start looking at is how can we do it with mixed numbers? How can we do it with improper fraction? And all that good stuff.
I'm going to get out of here.
We are out of here, I think that's 9:28. Something like that? Let me double check. 27. Right here. Okay, remember. If you're going to redo something, an assignment, you're going to turn it back in. Please get it to me. Make sure that page 67, 68 gets turned in. Alex, if you're done with that, you can turn that back in. I don't know if you're gonna fix it or what you're gonna do with it. So. And then if you still owe me work, you should check JMC. People still owe me Beth, Alex, and Sean, you still owe me something. Plus, if you have to page 67 or 68, everyone owes me.